Now let's take a look at the grain soft body simulation. Yes, grains can also be used to create soft body simulation. Let's see how we can do that. In here, let's create a geometry node and let's dive inside. And in here, I'm going to just create a rubber toy geometry. And in here, I'm going to just convert this to as a grain source. First, I'm going to just move this rubber toy up so that we have some distance between our ground plane, and in here I need to convert this into grain source. So let's in here type the grain source and let's add this. Let's visualize this into the grain source. To actually create the soft body simulation, we also have the option to create the constraint geometry, and we can create the constraint if you come over here onto the grain source, and down here we have the option to the explicit constraint, and if you enable the create option, and it will just create these it will create these polylines. And if I were to enable my point display, and here as you can see, we still have particles, we still have these points, but we also have these lines. These lines are connecting these particles. These lines what also called the constraint. So we are creating the constraint. These lines are the constraint, and in here I can play around with the search radius, and if you were to lower down the search radius, it will just remove these lines. If I were to increase the search radius, I can continue creating more and more of these line geometry, and I think the default value is fine. Let's see how we can now import these constraints into our solver, and I'm going to just disable this point display, and that was just to let you know that we do have these points. Let's create a pop net. Let's add this and connect this into the first input, and let's type inside. We just need to go into the pop source, and let's choose this to all points and uncheck the guide. Here as you can see, our particle has been imported. Let's go into the birth tab, and same thing, let's only import them onto the very first frame. I'm going to use the $FF, and for the comparison, let's add if our current frame number is equal to 1, which is only true at the very first frame. We are only importing our particle at the very first frame. And to make this simulation as a granular simulation, let's add a pop grain node. Pop grain, let's add this. We also need the gravity, so let's add a pop force node, and let's add this, and I'm going to just add a gravity value to -9.81. and we also need the ground plane for the collision, because if I were to hit play, and here you can see these grain particles falling forever. Let's add a ground plane in between so that we have something to collide with. Let's add a merge node, and I'm going to merge the ground plane with my simulation, and we need to reorganize this network because this organization matter in here. And in here, let's hit play, and we have our basic standard particle simulation, our grain simulation. Right now, here you can see we are only importing these points. If I were to change this to lit sphere, so right click and let's change our visualization to lit sphere. And here you can see we only importing our grains, and we are not importing our constraint geometry. If I go back, let's take a look at the grain source. If I zoom in right now, it is harder to see. Let's go in here and change the visualization to points. Here you can see we have these lines. These are the constraint, and right now we are not importing them. And to actually import these lines, these are what called the geometry. And let's go into the PopNet, and as you know, to actually import these polylines, all of these primitives, they are what called the geometry. So let's go into the sources, and right now we are using the all points method, which means that we are only importing the points, and we are removing any kind of geometry that we have on our input. And to actually import these constraints, let's go into the PopNet and change this to all geometry. And now we do have points. If I were to enable, points. I'm calling these points, calling these particles to points. We have the particles, but we now do have our these constraint geometry into our simulation. And now let's hit play again. And here you can see we have these lines, they are connected to our these sand particles. And right now these constraints are not doing anything. That is because we need to go into the pop grain. We can enable the constraint option, and we can do so if we go into the pop grain. And here you can see we have the option to enable the explicit constraint, and right now weight is set to 0, which means we do have constraint geometry, but we are actually not using them. To actually put them into use, we need to just increase the weight value to all the way up to 1. And now this pop grain node will use these constraints. And now if I were to hit play, and here you can see we have our this simulation, and now this simulation looks completely differently. And now let me change our this visualization, our this particle. Right click and let's change this to lit sphere so that we have the visualization, and let's hit play. And here you can see these lines, and I can now clearly see, and these lines are now keeping all of these particles together. They are not breaking, so these particles are not going far because they are connected together with these constraints. And I can control the stiffness, and right now we are using the constraint, and in here we have the option to adjust the stiffness. And if I were to increase the stiffness, we will see a much more stiffer connection. Here you can see we have this weird simulation. If I were to hit play, and here you can see we have this jiggly animation, and that is because, as you know, by default we are working with very low substeps. And let's increase the min and max substeps. I'm going to increase them to create a better simulation because we are adding more substeps. And let's hit play again. And now here you can see we have the simulation, and now its simulation looks completely different. Let's go into the pop grain, and in here that is the stiffness that is making these stiff constraints. If I were to lower down the stiffness value, and let's hit play again, and here you can see to actually right now we are using the more substeps, but we also have the constraint iteration. Let's go into the pop grain, and if I were to move this up below the particle separation, we have the constraint iteration. So these are the iteration that will go through to solve the constraint. And we also need to increase the constraint iteration as well, because now we are working with constraints. So in here I'm going to start this with 100, and that will create a accurate simulation. And now if I were to hit play, and here you will see that these constraints will going to be solved accurately, and we have this soft body looking animation. And let's go back. Right now we are also importing the ground plane. Let's go into the popnet, and I'm going to just remove this wildcard, and I'm going to explicitly say that please import only the pop object. So now we only have this geometry to actually deform this original geometry, because as you know, right now we are only working with these points. While it does looks like a soft body, we can actually deform this original mesh with these points as well. And the way that we can do that is by adding a point deform node. So if you type a point deform node, let me type point deform, and here we have it. And the point deform node has 3 inputs, and the first one is the mesh to deform, and I want to deform my rubber toy geometry. That is the mesh. Let's connect this. And the second is the rest point lattice. It needs the rest point, and I know that these are my rest point. So after the popnet, I can add a time shift node in here. Let's add a time shift node and connect this. And this time shift node by default, it does not do anything. It's just we have the animation in here. But what I can do onto the frame, right now we are using this $F expression to adjust the frame. I can just right click and delete the channel to, we have the delete channel, so let's click on it, and that will just delete the expression that we had. And now onto the time shift, I can say that please give me the frame number, and right now we are at the very first frame. If I want the frame number, let's say 40, I can go into the time shift node and I can say that please give me the frame number 40. Now if I type the frame number 40, and here you can see our this geometry will stay at the frame number 40. So in here I'm going to just type the frame number 1 because we only need the very first frame, and that is the static geometry, and that should be our rest point lattice. I'm going to organize this and plug this in here. That is the rest point lattice, and now it needs the deforming point lattice, the last one. And the last one, we are going to just plug this top net or this top network because it has this animation, and let's connect this onto the third. And now if we view the point deform node and let's hit play, and here as you can see we have our animation back, and right now our this animation is breaking. And I can go into the point deform node and I can just play around with the radius to smooth out all of our breakiness, and let's hit play again, and here we have our animation applied onto our original high res mesh. And in here I can go into the grain source and maybe let's link the point separation to create high res version, because as you know right now it is a very coarse simulation. Let's go into the PopNet and maybe let's copy the particle separation parameter, copy parameter. Let's go back to the grain source, paste this to as a relative reference. And now let's dive inside and I can in here create a high res version of our simulation by lowering down the particle separation. Let's change this to 0.05. And now we will get a much better representation of our geometry. And here you can see our simulation looks different. Let's go back and in here let's view this with the point deform node, and here you can see, and we can continue increasing this our resolution to add more of these particles. Onto the pop grains we have these explicit constraint, and if you scroll down we also have the option to break this constraint. And right now here you can see our constraints are not breaking, and I can enable the break constraint, and what that will do, it will look at this threshold. If the constraints are deforming that amount, this pop grain node will just delete this constraint. If I were to hit play, and here you will see that we will see the constraint breaking, and right now all of the constraint has been broken. And now here you can see we only have few constraints left, but most of them are broken. So maybe let's increase the breaking threshold so that I don't want that much breaking to be happening. And in here you will see that only the constraint that has more stress, they will going to be broken. Let me go back, let's hit rewind and play, and here you can see we have some of these parts, we have some of these clumping back. So all of these constraints are now broken, and by doing these constraints you can also create your mud type simulation. I'm going to just after the PopNet, maybe I can create this as a particle fluid surface because I want to convert this into mud. So let's add a particle fluid surface node and let's connect this in here, and that will just convert our points into mesh. And right now the particle separation value is too high, so let's lower this down to 0.05 or maybe 0.01. Here you can see I can see some of these particles and not all of them, and that is because this node requires a lot more particles, and right now we do not have that many particles, we have very sparse. Here you can see if I were to change this to points, here you can see we have these very sparse particles, and this node is designed to work with millions and millions of particles, but we only have few thousand, and that is why we have this issue. Let's go into the particle fluid surface. I can keep lowering this value down, particle separation. Let's lower this value down to even further, maybe 0.05. We might need to increase the radius, so attribute radius. This value is for the outputting, and to actually create this we need to adjust the p-scale value in here, or maybe I can just say simply say VDB from particles, and I can convert these particles to mesh by using our own VDB from particles node. So let's connect this in here, and I need to lower this value down 0.01, and there you go. We have right now this mesh. Because of the coarse resolution, I can clearly see these sphere. And after that, maybe let's smooth out this mesh. So I can say VDB smooth STF, because that is the STF representation. So let's add a VDB smooth STF node to smooth out these particles. Right now I'm using the mean value. I can change this to Gaussian. I can pick any of these algorithm that will work good. I think the mean value is fine. Let's adjust the filter radius to smooth out. Now we have this VDB, or this surface VDB, and right now, as you can see, we have this mud looking this mesh. Right now we do not have mesh, sorry, it is a surface VDB. And to actually convert this into mesh, we can say VDB convert VDB. So let's add a convert VDB in here. Let me add this, and I'm going to convert this into mesh. Right now it's set to volume. Let's change this to polygons, and now we have actual polygonal mesh, and which means now you can write out this cache, and it is ready to render. That's how you can actually deform or create your own mud simulation. Let's go into the PopNet. Let's go into the pop grain. We have the stiffness and we have the breaking threshold. And if I were to, let's continue increasing this, and maybe let's also increase the stiffness value, and that will create maybe let's adjust the visualization, because right now I can only see the constraint. So let's right click and change this to lit sphere again, so I can see my grain particles. And now let's hit play. We have the breaking threshold high, but we also have the stiffness high, and I think that breaking threshold is too high because no constraint has been broken. Maybe let's change this to 0.1 and let's hit play. We should see some of the broken constraint, or the head piece of geometry has been broken. Our head has been broken. Much of the geometry is staying as whole. I can continue lowering this value down even further, and let's hit play again. And we should see some more breakups in our constraint, and there you go. We have the constraint breakup. That's how you can create your pop grain constraint. You can create the grains to create the clumping, to create the mud, or if you want to achieve a soft body simulation. So you can create them using these constraints.